Hey everyone, and welcome to the Deep Dive. Today we're going to be diving deep into the world of large language models. LLMs for short. Whether you're a total newbie or you've been following LLMs for a while, this deep dive is for you. We're going to be breaking down this awesome quick start guide to large language models. It's got a ton of great info, so we've picked out the most interesting and helpful parts to make the most of your time. So first things first. What exactly are LLMs? Think of it this way. Like, imagine a super smart computer that can read and write and understand language, just like we do. But even better. And get this, LLMs are already having a huge impact on our lives, even if we don't realize it.
That's so true. And what's really mind-blowing is LLMs aren't just copying language. They're actually understanding it on a deep level. They use these things called transformers, which are like super-powered pattern recognition engines, specifically for language. And inside those transformers is this incredible mechanism called self-attention. It's like the LLM is focusing on the most important parts of a sentence, the same way we do when we're reading or listening.
It's wild, right? And this quick start guide, it highlights some amazing applications for LLMs. I was reading about how they're being used to create personalized education plans. So basically, the LLM adapts to each student's individual learning style. Imagine a world where every student has their own virtual tutor that can explain anything in a way that makes sense to them. That's the future of education right there. Oh, and in healthcare, LLMs are helping doctors make more accurate diagnoses. They can analyze mountains of medical research and patient data to find patterns and connections that humans might miss. It's like having a medical detective with superpowers.
It's true. And we're only just beginning to scratch the surface of what LLMs can do. As these models keep evolving, we can expect to see even more groundbreaking applications in fields like drug discovery, climate modeling, even the arts.
I can't wait to see what the future holds.
Yeah.
Okay, let's get practical for a second. I know what you're thinking, all this sounds amazing, but how do I actually get started with LLMs? Do I need like a PhD in computer science?
Not at all. This guide really breaks it down, even for beginners. It all starts with setting up your environment, which basically means getting the right software tools in place, like prepping your workshop. Before you start a woodworking project, you're going to need a programming language like Python and a machine learning library like PyTorch.
Okay, that makes sense.
Hmm.
Oh, the guide also mentions this Transformers library. That sounds pretty sci-fi, to be honest.
I know, right? But it's actually super helpful. It gives you access to pre-built LLM models, so you don't have to start from scratch. It's like having a set of blueprints to help you build your LLM. And for actually writing and running your code, you'll need a good IDE. That stands for Integrated Development Environment. It's like your digital workbench, where you can put all your tools and materials together. The guide mentions a few popular ones, like Jupyter, PyCharm, and Visual Studio Code. But it really comes down to personal preference.
Okay, so you've got your software, your blueprints, and your workbench.
Ah.
What's next? I mean, I'm guessing it takes a pretty powerful computer to train an LLM, right?
Yeah, that's one thing the guide really emphasizes. LLMs need a good brain to work with. They can be computationally intensive, especially the really large ones like GPT-3.
Oh yeah, I've heard about GPT-3. It's like the celebrity of the LLM world.
It is, and for good reason. It's massive. It has a staggering 175 billion parameters, which is basically a measure of its complexity, and that's what allows it to generate such realistic and creative text. But it also means it needs a lot of computing power to train and run.
Wow, that's incredible. Okay, so let's say we've got our software set up, we've chosen our model, and we've got a supercomputer ready to go. How do we actually train our LLM? Is it like teaching a child to speak?
You know, it really is. The Quick Start Guide breaks down the training process into a few key steps. And the first step is gathering a ton of text data. This could be anything: books, articles, websites, social media posts, you name it. The more data you have, the better your LLM will be at understanding and generating language.
Makes sense. The guide also mentions cleaning and annotating your data. What does that mean exactly?
Okay, imagine this. You wouldn't teach a child to speak using a book full of typos and errors, right? You'd want to make sure the language they're learning from is clear and accurate. Well, cleaning your data is kind of like that. It's about removing any errors, inconsistencies, or irrelevant information. And annotation is like adding labels to the data to help your LLM understand what it's looking at. For example, you might label a sentence as positive or negative to teach your LLM about sentiment analysis.
Got it. So we've got our clean labeled data ready to go, but then the guide says we need to divide it into 3 parts: a training set, a validation set, and a test set. Why is that so important?
It's like training for a marathon. You wouldn't want to run the whole race distance every day during training.
Right.
No way. You'd want to practice on different courses, vary your pace. test yourself under different conditions to make sure you're really ready for race day. Well, splitting the data for your LLM is kind of like that. We do it to make sure the LLM can generalize its knowledge and perform well on new data it's never seen before. The training set is like your daily practice runs, where the LLM learns the patterns in the data. The validation set is like a practice race, where you check how well the LLM is doing and make adjustments to your training if needed. And then the test set, that's the final marathon, where you see how the LLM performs on a totally new set of data, simulating real-world conditions.
Okay, that's a great analogy. So we've got our data prepped. We understand why we split it up. Now for the big decision, which LLM model do we choose?
There are a few powerful models out there, each with its strengths and weaknesses. Two of the most popular are GPT and BERT.
I've heard a lot about GPT-3, but what's the difference between GPT and BERT? How do we know which one is right for our project?
Well, GPT stands for Generative Pre-trained Transformer. And it's really good at, you guessed it, generating text. It's like a master storyteller. It can write poems, scripts, even code. BERT, on the other hand, stands for Bidirectional Encoder Representations from Transformers. It's more like a brilliant detective. It's really good at understanding the nuances of language. And it's often used for things like sentiment analysis, question answering, and language translation.
So it's like choosing between a creative writer and a logician. That makes sense. Okay, we've picked our model, trained it on our carefully prepared data. How do we know if it's actually any good?
That's where evaluation comes in. Just like we evaluate a student's performance through tests and quizzes, we need to evaluate our LLM to see how well it performs on the tasks we've trained it for.
Right, but how do we do that with an LLM? Do they get grades too?
It's not quite like giving them a letter grade, but we do use specific metrics to measure their performance. Let me give you an example. I was working on an LLM to analyze customer reviews, to identify areas for product improvement. One metric we used was accuracy, which tells you how often the model correctly classifies reviews as positive, negative, or neutral.
So how often it gets it right?
Exactly. And then there's precision, which measures how many of the positive reviews the model identified were actually positive, and recall, which tells us how many of the actual positive reviews the model was able to catch.
So precision is about avoiding false positives, and recall is about making sure we don't miss anything important. What about that F1 score I keep hearing about?
Yes, the F1 score. It basically gives you a balanced view of both precision and recall. It helps you understand how well the model balances between correctly identifying positive reviews, while also minimizing false positives. By monitoring these metrics during training, we could see how well the LLM was learning and make adjustments to improve its performance. It's like giving our LLM targeted feedback to help it
So it's like coaching your LLM to be the best it can be. I love it. Okay, so we've trained our LLM, we've evaluated its performance, and we're feeling pretty confident. Now what? Do we just set it loose on the world?
time to deploy it, which basically means making your LLM accessible to users or integrating it into real-world applications. It's like taking your LLM out of the training ground and putting it to work in the real world. The guide outlines different deployment options, but it can be as simple as creating an API.
An API. I've heard that term thrown around, but to be honest, it's always sounded a bit intimidating.
I get it. But think of an API like a translator between your LLM and the real world. It allows other software applications to communicate with your LLM, sending it information and receiving responses. For example, if you wanted to create a chatbot for your website, you would use an API to connect the chatbot interface to your LLM, allowing users to interact with it seamlessly.
So it's like the bridge between the LLM and the outside world,
Yeah.
allowing them to exchange information and make magic happen. This is fascinating stuff. We've covered a lot of ground today, but we've only just scratched the surface. We've learned what LLMs are, how they work, and even how to get started with training and deploying them. But there's so much more to explore. And in the next part, we're going to dive even deeper into some of the more advanced concepts and explore even more mind-blowing applications. So stay tuned.
Welcome back to the deep dive. We're picking up right where we left off, exploring the amazing world of LLMs.
Last time we talked about the basics, like what LLMs are, how they work, even how to start training one.
Yeah.
But this guide, it goes even deeper. And I gotta say, some of it had me a little lost.
Well, that's what we're here for. Let's unpack some of those more advanced ideas. Let's start with something called transfer learning.
Transfer learning sounds kind of mysterious.
It's a cool concept. It's basically about using what an LLM already knows to make training faster and more efficient. Think of it like learning to play a new instrument, let's say the piano. You wouldn't start from scratch, would you?
Not if I could help it.
Exactly, if you already know how to read music. Or bring another instrument. You could use that knowledge to learn the piano faster.
So with transfer learning, we're taking an LLM that's already learned a lot about language, and we're kind of adapting it to a new task, like using your musical skills to learn a new instrument.
Exactly. Instead of training an LLM from nothing, which takes forever and a ton of resources, we can use a pre-trained LLM as a starting point. It's already learned a lot about language structure, grammar, even some general knowledge, from processing massive amounts of data.
That makes a lot of sense. So it's like giving our LLM a head start. I see the guide mentions a couple of ways to do this. Fine-tuning and feature extraction. What's the difference?
Okay, think of fine-tuning like taking your piano skills and focusing on a specific type of music, like jazz. You're taking those skills and adapting them to a certain style or task. With LLMs, fine-tuning means taking a pre-trained model and training it further on a smaller, more specific data set that's related to the task you want it to do. Like, let's say you want an LLM to write marketing copy. You could fine-tune a pre-trained language model on a data set of really good marketing materials, and it would learn to generate text. That's more aligned with that style and purpose.
So it's like specializing your LLM, giving it a specific job to do. What about feature extraction?
Feature extraction is a little different. It's more like using your musical knowledge to analyze a new piece of music, even if you've never played it before. You're using what you know to extract meaningful information from the music. With LLMs, feature extraction means using a pre-trained model to analyze text and extract these features or representations. And then you can use those features to train a separate model for your specific task, even if that task is completely different from what the pre-trained model was originally for.
It's like using the LLM as a powerful tool to break down language and find the hidden gems. That's clever.
Yeah.
Speaking of powerful, we've talked about how training an LLM takes a lot of computing power, especially those massive models like GPT-3. The guide talks about handling large data sets. And I got to be honest, that part was a little overwhelming for me.
I hear you. When you're dealing with data sets that are huge, like terabytes or even petabytes of data, you need the right tools to manage it all. Imagine trying to read an entire library's worth of books all at once.
Yeah, my brain would explode.
Totally. That's why we need ways to break down these massive data sets into manageable chunks. The guide recommends using these things called distributed storage solutions. Think of it like having multiple bookshelves to organize all those books. Services like HDFS, Amazon S3, or Google Cloud Storage let you spread your data across multiple computers, so you're not limited by the storage of just one machine.
Like having a team of librarians
Yeah.
helping you manage all those books.
Perfect analogy. And then when it comes to actually feeding that data into your LLM during training, you need to use efficient data loading libraries. These libraries are like those little book carts librarians use to move books around quickly and easily.
Okay, so we've got our data organized, our models training, but what about performance? How can we make sure our LLM is running as smoothly and efficiently as possible?
Great question. Performance optimization is super important, especially when you're using LLMs in the real world, where speed and responsiveness are key.
I can imagine. No one wants to wait forever for a chatbot to respond.
Exactly. One technique the guide mentions is caching, which is basically like keeping frequently used books on a special shelf for quick access. You're storing the results of common calculations, so the LLM doesn't have to recalculate them every time. It saves a ton of time and resources.
Smart. Any other performance boosting tricks?
You can also optimize the code itself, make sure it's written to run efficiently on the hardware you're using. It's like organizing the library so people can find the books they need more quickly.
So it's all about decluttering and streamlining the code.
Pretty much. And then there are techniques like pruning and quantization. They involve simplifying the LLM structure without losing too much accuracy, like taking a really long book and condensing it into a shorter version. That still gets the main points across.
Okay, that makes sense. The guide also dives into some other really cool concepts, things like in-context learning, few-shot learning, and even zero-shot learning. These sound kind of like magic to me.
They're pretty amazing, and they represent a new way of thinking about how we train and use LLMs. We used to rely on tons and tons of labeled data to train LLMs, but with these new techniques, we can do more with less data.
So instead of feeding the LLM mountains of data, we can teach to learn with fewer examples.
Exactly. Let's start with in-context learning. Imagine you're teaching someone a new word. You could give them a dictionary definition, but you could also just use the word naturally in a sentence, and they'd probably figure out the meaning from the context.
Right, clicks because of how it's used.
Exactly. Well, in-context learning is similar. You give the LLM a few examples, or a prompt that includes the task you want it to do. And it uses that context to figure out what to do, even without specific training on that particular task.
Like giving the LLM clues instead of step-by-step instructions.
I like that. Then there's few-shot learning. It takes in-context learning a step further. Instead of a bunch of examples, you only give the LLM a few, and it still manages to learn the task.
Wow, that's pretty impressive.
It is. And then there's zero-shot learning, which is the most mind-blowing of them all. It lets LLMs do tasks they've never been specifically trained for, just by using their knowledge of language and the world.
Hold on, that sounds impossible. How could an LLM know what to do if it's never seen an example of that task before?
It comes down to the LLM's ability to understand the connections between words and concepts. It's like having a giant encyclopedia in its brain. For example, you could ask a zero-shot LLM to translate a phrase from English to Spanish. Even if it's never been specifically trained on translation, it can still use its knowledge of both languages to figure out the equivalent phrase.
That's amazing. It's like the LLM is thinking for itself.
In a way, it is. It's using its knowledge base to solve new problems. It really shows how powerful and flexible these large language models can be. But of course, with all this power comes a responsibility to use it ethically.
That's a crucial point, especially as LLMs become more advanced and more integrated into our lives.
I agree. We need to make sure they're being used for good,
Yeah.
and that we're thinking about the potential risks and unintended consequences. But we'll dive into those topics more in the next part of our deep dive.
Looking forward to it. This has been a fascinating exploration of some of the more advanced concepts in the LLM world. We've learned about transfer learning, data handling, performance optimization, even those incredible few-shot and zero-shot learning techniques. And in the final part, we'll wrap things up by exploring some real-world applications and discussing the ethical considerations that are so important in this rapidly evolving field. So stay with us. All right, welcome back to the deep dive. It's time for the grand finale of our LLM exploration.
I'm really excited to get into some real-world examples, see how these LLMs are actually being used out there.
Me too. You know, we spent the last two parts laying the groundwork, understanding what LLMs are, how they work, how to train them. But now it's time to see them in action, solving real problems, changing the way we live and work. In this quick start guide, it's full of fascinating case studies that really show how versatile LLMs can be. One that really caught my eye was about this telecom company that used an LLM to completely revamp their customer support.
Oh, yeah, I remember that one. They were drowning in customer inquiries. Long wait times, frustrated customers.
A total nightmare for any business, right?
Absolutely. But their solution was brilliant. They created a chatbot powered by an LLM that was trained on a massive data set of past customer interactions.
So basically, the chatbot could understand and respond to all sorts of customer questions, just like a human rep.
Exactly. And it was available 24/7, so customers could get help whenever they needed it. No more waiting on hold.
What were the results like? I bet they were pretty happy with it.
They were amazing. Response times went way down. Customer satisfaction went way up.
It's incredible what LLMs can do, streamlining things, making customers happier,
Yeah,
and all while freeing up human agents to focus on more complicated issues.
absolutely. Oh, and there was another case study I found fascinating about this law firm that was using LLMs for legal research.
Oh yeah, that's a perfect use case for LLMs. Legal research can be so time-consuming, attorneys spending hours and hours poring over documents.
It's like finding a needle in a haystack. But LLMs, they can analyze thousands of documents in seconds, finding relevant case law, summarizing key points.
It's like having a superpowered research assistant on your team.
Right. So this law firm, they developed this LLM-powered tool that made research faster, but also more accurate and efficient.
The guide mentioned that the tool had these advanced semantic search capabilities, so attorneys could search using natural language instead of just keywords.
Exactly. So they could just type in a question or a concept, and the LLM would understand what they were looking for and find relevant cases, even if the wording was different in the documents.
Game changer. This is going to free up so much time for attorneys, so they can focus on strategy and other important tasks, while the LLM handles the research.
It's a huge shift.
And speaking of big changes, we can't forget about the impact LLMs are having on education. The guide talks about this online platform that created an LLM-powered tutor.
Oh, that's a really cool application.
Right, it's like a virtual tutor that can tailor its teaching style to each student.
Personalized lessons, customized feedback,
Exactly, like having a teacher who really understands your strengths and weaknesses.
and can guide you in the most effective way. So this platform, they trained their LLM tutor on a massive data set of educational materials.
Textbooks, lectures, practice problems.
Everything. And now it can answer questions, provide explanations, even create personalized quizzes and exercises.
It's making education more engaging, more effective, more accessible for everyone.
Couldn't agree more. And then there's the work being done in drug discovery, which is truly revolutionary.
Yeah, we touched on this earlier, but the guide really goes into detail about how LLMs are speeding up the process of finding new cures.
Traditional drug discovery, it's so slow and expensive.
And there's no guarantee it'll even work.
Exactly. But LLMs are changing everything. They can analyze huge amounts of data, identify promising drug candidates, even design new molecules with specific properties.
It's like having a team of brilliant scientists working around the clock.
The guide highlights this pharmaceutical company. They used an LLM to analyze chemical data, propose new compound structures, and predict how those compounds would interact with biological targets.
That's mind-blowing. LLMs helping to develop life-saving medicines and getting them to people faster.
The potential impact is huge.
It really is. These are just a few examples of how LLMs are being used to solve real-world problems across so many different industries.
And we're just getting started.
I know. This technology is evolving so quickly.
It's a really exciting time to be involved in this field.
It's been an incredible journey exploring the world of LLMs with you.
The pleasure was all mine.
We've learned so much, from the basics to the mind-blowing applications, and I hope our listeners feel inspired to dive in and explore the possibilities for themselves.
There are tons of resources out there and a really supportive community.
So check out the guide, join the conversation, and keep learning. That's all for the deep dive. Thanks for joining us.